Hello everybody. Today, we are going to learn about limit properties. We will go through the main limit properties one by one. Then, we will practice using them to evaluate limits. Let's get started. Property 1. The limit of a constant. The first property is the limit of a constant. This means that the limit of a constant is equal to the constant itself. For example, imagine that we have the function f of x equals 2. If we graph this function, we get a horizontal line at y equals 2. Now, let's say we want to find the limit as x approaches 6. The answer is 2. If x approaches -1, the answer is still 2. It does not matter what value x approaches. The function is always equal to 2. Therefore, the limit is also always equal to 2. Property 2. The limit of x. The second property is the limit of x as x approaches a. This is equal to a. Basically, imagine that we have the function f of x equals x. The graph is a straight line. For every point on the function, the y value is equal to the x value. So, if x approaches a, the y value also approaches a. For example, if we have the limit as x approaches 2 of x, the answer is 2. Property 3. The sum and difference property. The next property is the sum and difference property. This property says that the limit of a sum or difference is equal to the sum or difference of the limits. Let's look at an example. We have the limit as x approaches 2 of x plus 5. We can separate this into two limits. The limit as x approaches 2 of x, plus the limit as x approaches 2 of 5. We already know that the limit of x is the value that x approaches. So the first limit is 2. The second limit is a constant. The limit of a constant is just the constant itself. So that limit is 5. Therefore, we have 2 plus 5. That gives us 7. So our final answer is 7. Property 4. The product property. The next property is the product property. The limit of a product is equal to the product of the limits. For example, let's look at the limit as x approaches 5 of x squared. We can think of x squared as x times x. So we can separate this into two limits. The limit as x approaches 5 of x. Multiplied by the limit as x approaches 5 of x. Both of these limits are 5. So we have 5 times 5. That gives us 25. Therefore, our answer is 25. Property 5. The constant multiple property. The fifth property is the constant multiple property. This property says that if we have a constant multiplied by a function, we can take the constant outside of the limit. For example, let's say we have the limit as x approaches 3 of 5x. We can take the 5 outside of the limit. So we have 5 multiplied by the limit as x approaches 3 of x. The limit of x is 3. Therefore, we have 5 times 3. That gives us 15. So our answer is 15. Property 6. The quotient property. The next property is the quotient property. The limit of a quotient is equal to the quotient of the limits. In other words, we can separate the numerator and denominator into their own limits. However, there is one important condition. The denominator cannot equal 0. If the denominator equals 0, the expression is undefined. Property 7. The power property. The next property is the power property. the limit of a function raised to a power is equal to the limit of the function raised to that same power. For example, let's say we have the limit as x approaches 3 of x minus 2, all raised to the fourth power. We can first find the limit of x minus 2. The limit of x is 3, so we have 3 minus 2. That gives us 1. Now we raise 1 to the fourth power. 1 to the fourth power is 1. Therefore, our answer is 1. Property 8, the root property. The root property is very similar to the power property. If we have a square root, we can take the limit of what is inside the square root first. Then, we take the square root of our answer. For example, if we have the limit as x approaches a of the square root of f of x, we can find the limit of f of x first. Then, we take the square root. Practice examples. Now let's practice using these properties. Example 1. Let's start with the limit as x approaches 5 of 5. Since 5 is a constant, the limit is simply 5. So our answer is 5. Example 2. Now let's try the limit as x approaches 2. Thank you for watching.